Hello, everyone. We are here to talk about contributing. Hopefully you're here to get started contributing. Fingers crossed. My name is Emily Burns. I work at Netflix. I'm a senior software engineer on the delivery engineering team, and we run and operate Spinnaker and build Spinnaker. And this is Lars. He works at Google, also on Spinnaker, and heads up the open source portion of their team. So today, we're going to give you a walkthrough of the Spinnaker architecture, like an overview of what the microservices do, and then a specific walkthrough for a scenario that you might see. And then we're going to talk about how to develop locally. Then we're going to do some live demos of changes, which will go amazingly. And then we're going to talk about beginner-friendly starting points and becoming a contributor, and we'll take questions about that. So if at any point you have like a clarifying question or you want more detail about a specific slide, feel free to stop me or stop Lars and ask. And then if you want to talk about more general things that we don't cover, we'll do questions at the end. So Spinnaker architecture. Spinnaker is made up of a bunch of microservices, and they all have specific roles. And some are super critical to the functionality of Spinnaker, and some provide more edge functionality that's maybe not mission critical. So this is the architecture diagram that is from the Spinnaker IO website that you might have seen before, and we're going to walk through that. So the top level, the green boxes with the people next to them, those are what you might interact with as a customer or user of Spinnaker. So deck is the microservice, that's the UI, and it is built in a combination of Angular and React, but all new code we would love to be submitted in React if possible. And then custom script or API caller would not usually interact with deck, but that's another entry point into Spinnaker. So it's called out as a box here because we have a lot of people at Netflix that do that. So those arrows point to Gate, which is the microservice that is the API gateway. And so this exposes all the functionality of Spinnaker through one point. And we have a Swagger endpoint that when you stand up Gate, you'll see. And so you can play around with the endpoints and get data that way and see how to custom script. From Gate, it sends all the traffic to all the other services. So the next big thing is Orca. Orca is the orchestration engine. So far, these are named pretty much to make sense, hopefully. And so Orca does all of the orchestration of pipelines and tasks and coordinating the sequence in which things happen and monitoring all of those. Orca talks to CloudDriver, and CloudDriver is the microservice that talks to the specific cloud pieces. So all of the logic that deals with like AWS or Kubernetes or like actually talking to the cloud, actually making changes, happens in CloudDriver. So that's kind of the core flow for what you would think and what you'd understand with the actions. So there are some other services as well. Let's see, starting from the right here, Igor talks to Jenkins and the Docker registry and does indexing there and publishes events to Echo when new things happen. Echo is the eventing service, which takes events from inside Spinnaker and puts them outside Spinnaker. So Echo will send events to Slack, things like that. Front 50 is the persistent data microservice, which is backed by S3 for Amazon and GCS for Google, and there are some other backings too. This is where all of the application data is stored, but not where like the task history or execution history is stored. Fiat is authorization, and so that's a newer service, and it deals with access control for accounts and pipelines on a more granular level. Roscoe is the bakery. It's based on Packer. And then Kayenta is the canary analysis tool, which there have been a bunch of other talks about. Kayenta is not, to run Kayenta, you don't need Spinnaker, but it uses Orca as the way it orchestrates, but a separate Orca. So there's a summary of that, all that on the side too. So now we're going to walk through a specific event and how that flows through Spinnaker. So we're going to talk about a Docker trigger. and what happens from when the Docker event is published all the way to the end of the pipeline. So you can see how the microservices interact. And all of the files that I reference are linked at the bottom, and our slides will be published so you can follow along if you want or explore later. So the first thing that happens when you have a Docker trigger is you upload a new Docker version, so a new tag, and Igor is the one that deals with that in indexing Docker. And so when it sees a new tag, it publishes an event to Echo that says, hey, there's been a new Docker tag. Echo takes that event and it knows what to do with it. So Echo is periodically pulling pipelines from Front 50, and it will refresh those several times a minute. And it looks through all those pipelines and it decides if this event matches the specific trigger that anyone has defined on their pipeline. So it looks at the regex for the name of the tag and different things like that, whether the pipeline is enabled or disabled. And then if it determines there is a match or many matches for this new event, then it sends an event to Orca to start the pipeline. So Orca does the actual work. Orca pulls the pipeline again from Front 50, make sure it has the most up-to-date copy of the pipeline. And then it runs all the stages that are defined in the pipeline. And it might reach out to different services, like if it's a pipeline that has a canary in it, it might reach out to Kayenta. If it has needs to bake something, it might reach out to Roscoe. If it needs to change the cloud, it might reach out to CloudDriver. You get the idea. It communicates with these microservices. It monitors those tasks. And these are all defined in stages in Orca. Events for each pipeline stage are sent to Echo to maybe propagate out into Slack events. So you've seen your pipeline start, Slack, pipeline end, Slack event. That goes back through Echo. And then once the pipeline, as the pipeline's running and once it's finished, it's persisted in a database. So Redis has been the primary database for a long time, but we've just recently added support for SQL as a backing store for Orca because a lot of people like it when their pipeline execution history doesn't go away. And so we've been making effort to make that more reliable.
Okay, so before we actually make a demo or do a demo and show how this stuff works, I will talk briefly about Halyard. Has everyone heard of Halyard before? Anyone not heard of Halyard? Who's used Halyard? I will explain what Halyard is. That's great. It's the best service in Spinnaker. Who's used Halyard actually to configure their Spinnaker? Cool, awesome. It's good? Oh, thank you. That's all I needed to hear. Okay, so we use it. We built it with the open source launch of Spinnaker to make configuring and installing Spinnaker easier. Spinnaker is like 10 microservices like you saw. Each of them has dozens to hundreds of config properties. In fact, actually I have a link right here. And this is just the stuff that Halyard exposes. The table of contents is massive, and this is mostly added by the community. It's like codified configuration for Spinnaker, basically, and it goes on for pages and pages. So we need some way, basically, to make that stuff documentable and make sure it stays up to date with various versions of Spinnaker. We use it all over the place. It's what drives the deployment in the Helm chart. Our internal Spinnaker deployments are deployed by Halyard. We do it for code lab provisioning. We have a bunch of big customers using it. It's all over the place. But one thing that was missing up until 6 months ago was using Halyard for development. So say, for example, you have Spinnaker in production, you're running Spinnaker, something's wrong, and you want to make a code change to exactly reproduce that issue and insert some debugger or whatever. You can take Halyard, take that exact same configuration you have for your production Spinnaker, have it clone those services from source, run them at the exact same commits that we built those services from, and then hopefully troubleshoot a little easier. So this was added by Brandon Nelson. He's on the Google team. He joined a couple months ago. This was the backend he added for Halyard. And Scott Seward, who's in the audience back there, wrote a great getting started guide that actually makes this really easy to walk through and get set up. All of our new engineers are using this to develop Spinnaker. All of our dev VMs that we have running are managed by Halyard in this exact way. Right, so to talk a little bit about the LocalGit backend that was added a couple months ago, before we actually jump into it. So basically what it does is you say, I want to deploy Spinnaker locally. You give it a configurable folder that it clones stuff into. In this case, we say it's going to go into dev Spinnaker. And like Emily said, we have all these different components. They each get their own directory. They each get their own lifecycle scripts. They each get logs written out into a separate folder. And then you can run the typical Halyard commands to manage the lifecycle, the same way you do for any other Spinnaker deployment, whether it's to Kubernetes or to your local machine. The big difference, though, is that you can also, instead of just assigning it fixed versions, say, clone for me the upstream master branch and run that across all services, or for this subset of services that I want to have pointing at certain branches. Big call out right here is the first time you do this, it downloads basically half the internet in terms of Gradle dependencies. So it takes like 45 minutes to start. Luckily, we have someone on our team trying to split that out, and you can maybe somewhat prune down the dependencies. But if you go home and run this, it'll take forever the first time you run it. Don't be alarmed. Okay, so Emily found a great thing we're going to fix in Spinnaker. It's an issue right now, and namely, so you run the webhook stage. It's a stage in Spinnaker that lets you call out to some third-party service. Issue is you don't know what the status code is that you get back. You get like a status code message, but not the status code number, and we're going to add that in Spinnaker right now. So there's a couple beginner-friendly starting points. If you don't actually want to write code necessarily, and you just want to help the community out, you could start by triaging an issue. We actually use these labels very heavily in the GitHub project. I know, though, for some reason, GitHub doesn't actually let you add labels unless you have commit privileges, which is kind of odd. So we have the Spinnaker bot, which watches our repos for us, and you can use these kinds of commands like add label, remove label, to tag things. So either if you're filing a new issue or you see something that's not been tagged, and if you add some tags, that helps us out quite a bit. If you're looking at the docs and you see there's a typo or something's not quite right or doesn't make sense, you have in the top right, actually, for every page, this little suggest and edit button. You can just click on that. It brings you right to the web editor in GitHub, and you can make a change, and it'll let you commit it right back or open a PR. If you actually want to write code, we have this beginner-friendly label here, which we rely on, or we'll add to issues when we think they're very easy to add. Actually, funny story, I was looking for an example to take a screenshot of, and then I think Michael's in the audience right now, was really great and actually responded to one of these, and then closed the issue, fixed it, and it was kind of like the perfect story. But so typically if someone adds this label, that means they know that it's easy to contribute, and they'll be able to coach you through it as well too. So, and they're typically added to things that are pretty easy to fix and close. Finally, if you have an idea for like a very big contribution, like you want to add a new stage, you want to add a new provider, it would be really helpful if you wrote a design doc. It doesn't have to be very formal, but the idea is that the reviewers kind of want to understand what your goals are, how you're going to split this up, and they'll also be able to provide you feedback on how to implement this in the context of what the other people in the Spinnaker community are doing. You should try and hit a couple of key points. So one, motivations, why are you doing it? Two, implementation details, roughly what change you plan to make. It doesn't have to be pointing at lines in code and showing exactly how you're going to implement it, but at the very least give us an idea of the change you're making. Milestones help us quite a bit. It helps us put things into that roadmap doc so we can say, here's when certain features are arriving, and it also helps us plan the work that we're doing on the project. And then finally, if there's some sort of alternative, easily thought of solution that you don't think makes sense, put it into some sort of alternatives considered section at the end of the doc, because people typically will wind up asking those questions. With that, I'm going to hand it back to Emily.
So we thought we'd talk about becoming a committer as well. Andy talked about governance, and so this past summer we've really formalized like the question of how do you get commit privileges, who can do things, do you have to be buddy-buddy with someone? The answer is now no. So a great place to start and to show your involvement in the community is to comment on issues and PRs. So reproduce issues, comment on PRs and understand them and say when a function is not clear or too big or should be broken up. Enforce the style guidelines that are on the contributing submitting thing. And test to make sure a PR fixes a bug. That's all really helpful, and it helps to show activity for you that you're invested in the community, you're understanding the things, and you're helping out. When you'd like to fix a bug or build a feature, we have conventions. They're here linked. And so you can open a PR, and then if you don't get timely reviews, there's a couple of things to do. You can mention Spinnaker reviewers, which emails us. You can reach out in the appropriate Slack channel that's like the Kubernetes Slack or the Halyard Tech, depending on which feature you're dealing with. And then if you're in the community, you probably know who has a lot of stake in the feature and who cares about it, so you can also talk to them directly, which is less preferred but more successful. So the details are here. So on how to become a committer, you kind of move through the flow that Andy talked about yesterday. So we're looking for you to be involved in the community, contributing several smaller features, have some PRs closed. We're looking for you to have been involved in the community for a while. And then ideally, we want you to have some stake in Spinnaker, so like your company is using it and you care about the future and where it goes and you want to help us on this journey. Any questions about that? Additionally, Hacktoberfest is going on right now. I don't know if you guys heard of it. It's put on by DigitalOcean, I think. And so if you sign up with them and you have 5 PRs merged in October, they will send you a free t-shirt and some stickers. So you can do any of the things we talked about today to help you win another free t-shirt.